Number 15, their question to you is, does this example illustrate the population paradox? And it's a group of 3 regional airports, and they have hired a company to increase security, and the contract calls for 145 security personnel to be apportioned to the airports. Yes, I should have circled that originally. According to the number of passengers using each airport each week. 2 years later, reminds me of a SpongeBob. 2 years later, the number of passengers per week has increased at the 3 airports, so the 145 security personnel are reallocated. We show these data in a given table, and they want to know, does this example illustrate the population paradox? So, the time now, I guess, the original information, and you've got Allentown, Bakerstown, and Columbia City, and I guess I'll do all those in blue. I don't know. So we've got A and B and C. So I went ahead and did the total in green for that time, and it added up to 149,226. So I took the total population, divided it by the number of security personnel to be apportioned, which is 145, giving me a standard divisor of 1029.14. And what I then did was take each population, that number, and that number, and divided them by the standard divisor, which gave me 116.70 for Allentown. I got a 5.36 for Allenport, Bakerstown, and Columbia City when I did it. That gave me 22.93. Now, the population paradox, I need to take you back to a previous slide, which was this last one right here. The population paradox. They're asking me, does their example show the population paradox? The only time the population paradox could occur is under the Hamilton method. It does not occur using Jefferson, nor Adams, nor Webster. So, the only way to show that it does is by the Hamilton method. So, Hamilton, as you recall, would look at, use yellow on this. He would look at, okay, it's 116, that's the whole number. It's 5, that's the whole number. It's 22, that's the whole number. And we added that up. Does it come out to be 145 when you add them up? Nope, it's only 143. So there's 2 more seats, right? And the 2 seats would go to the 2 largest. Well, 0.93 is the biggest. 0.70 is the next biggest. So 1 seat goes here, and 1 seat, security personnel goes there. So Allenport, would get 117. Bakerstown still just has 5. And, Columbia City would have 23. And when you add that up, there's the 145. Okay? So fast forward 2 years, and we're going to do the same thing again with Allentown. I don't know why I keep wanting to say Allentown. It's Allenport. It's Bakerstown. I'll just say A, B, and C. All right? So, but now what you have to do is use these numbers. the new populations. So take those three numbers, these three numbers here, each individually, and still divide them by 145, because that didn't change. It says right here, are reallocated. So when I do it this time, when I take this number, divided it by 145, I got 117.36. When I took this number, 5596, and divided it by the 145, I got 5.28. And then the last one, C, this number here, when I divided it by 145, I got 22.35. Now keep in mind, we are doing, let's see, I need another color. What have I got? I'll go with gray this time. Okay, so again, this is Hamilton. So Hamilton would give them the whole numbers. So 117, 5, and 22. But when I add that up, I get 144. There's one more seat, and it's going to go to the largest, which is the 0.36. So add one here, and you've got 118 and 5 and 22. And when I add that up, I do get 145. So that one has been allocated correctly. Now, what I need to look at is, hang on a second. Okay, so next slide takes me to their question. Does the population paradox occur with the figures for passengers per week 2 years later? And your choices are yes, yes, no, and no. Yes, okay. Let's go back to what the population paradox says. If I can find that slide. Where's the population paradox? No, where's the population paradox? I shall find it. That's apportionment. What happened? I jumped around. Jump around. Where's the paradoxes? They're way back up here. Here it is. The population paradox occurs when state A's population is growing faster than state B's, yet A loses a representatives to state B. Okay, and in this case, it's not representatives, it is security personnel. So let's go back down here and look at what we had here. Okay. Sorry. Okay. Looks like Allenport went from 120,000 to 124,000. Bakerstown went to 5. That increased, and so all three of them increased. All three of them did increase. And oh yeah, what I need to figure out is let's see, who changed? B did not change. Okay. B right here, B did not change. They stayed 5 here and 5 there. A had 117 and now they have 118. C has 23 and dropped to 22. So it looks like C lost a security personnel to A, and the question is, does it illustrate the population paradox? We have to figure out the percentage change here. So I'm only dealing with A and C because B stayed the same. And on A, they went from their new one. Remember, it's new minus old divided by old. And I may run, yeah, I think I'm going to run out of time here. So let me do a part 2 to this.